Hello everybody, I'm Nick, and in this video I'm going to show you how to work with images like a pro in .NET. The many scenarios where you might need to work with photos, images, logos, things that need to be uploaded, retrieved, deleted, updated, resized, apply effects on it. So in this video I'm going to show you how to do all that properly and also show you how to do that in an optimized flow where your user gets the best possible experience by just uploading a photo and all the processing happening asynchronously in a very nice way. Now in this video, to upload those images, I will be using AWS S3. So this video is sponsored by AWS, and if you want to check how to get some free credits, check the link in the description. And if you want to know way more about how you can use AWS as a C# developer, AWS has fully sponsored a full-length course on dometrain.com. So I'm going to put a link in the description. If you want to take that course, it covers tons of services. And it's completely free. You don't have to do anything. Just sign up and it's yours to keep forever. So check that in the description down below. If you like those videos, make sure to subscribe. And for more training, check out my courses on dometrain.com. Okay, let me show you what I have here. I have a simple customers API and I'm going to go straight ahead and run it. And this is just your basic REST sort of CRUD API where you can create a customer, get a customer, delete, update, and so on. So I'm gonna go to Postman here and try to create Nick Chapsas in this API, this customer's endpoint. And we have a post request, we fire off, and as you can see, we created Nick, and I can use Nick over here with its ID to get Nick back. If the ID is wrong or it doesn't exist, then I'm gonna get a 404 because that thing does not exist. And this is using a real database. So this is using a DynamoDB database in AWS. We can actually check it out here. So I'm in the AWS dashboard. I'm gonna search for DynamoDB over here. I'm gonna find the service and then search for the table. So it is this customers table over here. I'm gonna look for the items, explore items, and as you can see, we have one item, and this is what we're getting in that API over here. So we have a bunch of values as well as the updated ad when this thing was updated, and that is it. Now what I want to do is actually write functionality that allows me to upload the image for that user. So for me, it's going to be my face. Now to store those images, we're going to use a service in AWS called S3. S3 stands for Simple Storage Service, and it allows you to store all types of files, but we're going to be focusing on images for this video. But we can actually store any type of file, stream it, videos, whatever you want. It is supported here. In S3, you store your items in buckets. So I'm gonna go ahead and just name this bucket Nick Chapsas Video and select London as the region. And I'm not gonna touch anything in terms of versioning, the policy and so on. I'm gonna just leave it as it is. But there's some very, very advanced features which we can actually take a look at in a future video. So leave it as it is, create the bucket. And now that I have the bucket, I can start adding items in the bucket. What I want to build is functionality that allows me to upload images in ASP.NET Core and push them into S3. Now to do the uploading, I want to create a new controller. So I'm going to say customer image controller. So we're going to create that. It's going to be an API controller and it's going to extend the controller base class. And that is it. Now we're going to start creating the endpoints. The first one I want is the upload one, which is going to be the post one. Now this post endpoint, this upload endpoint will be the one where we're going to be creating a new image, but we're also going to be using it to upload an image based on upsertion. Because you can only have one profile image per user, we're going to be using the user's user ID as the identifier to find the image in S3. So in terms of endpoint, we're going to have a public async task of action result over here. And that's going to be a post on the customer's endpoint. So the same thing that the customer's controller actually is using over here, but then we accept the user ID as a parameter and then we say image. The reason why we don't use plural, which is more common with REST APIs, for example, here, is because you can only have one image in the concept of this profile photo. So that's why we don't actually need to do that. Plus, this is not really a REST API technically. So what we want to say is upload, and we're going to grab from route the GUID, the user ID, and we also want to grab the bytes that the user will be uploading. We're going to be using the form to upload the data. So what I'm going to say is from form over here, and we're going to say that the name of the value is just data. It could be image, it could be data, it could be whatever you want. And the type will be the iForm file type. So if you want to upload any type, not just images, you can do that from form like that. Now here I'm just going to say return OK, and I will need to implement the service that will do the uploading. Now to do that, I will need the S3 SDK. The S3 SDK contains all the code necessary for the networking and all the operations that I need to do against S3. So what I'll do first is go here and search for S3 and find the AWS SDK S3 and install it. That is it. And then I'm going to go to services and create a new customer image service class. And of course, I'm going to get a matching interface just underneath that over here. Now I'm going to start with a simple method in the interface, and that is going to be the upload image async method that accepts an ID, which is the user ID, which is also going to be the file ID, and then the file iForm file object itself. Now, in some cases, you might want to only grab the values you want from the form file and pass them down into this invocation, into this method. But here, because there's so many things you might need, I'm going to leave it as the form file, and you can choose to change it any way you want for your own application. So I'm going to go here and say that this implements this interface, and I'm going to inject what I need to start dealing with S3, which is a private read-only Amazon S3. So this will give me access to all the S3 operations. I'm also going to have a private const string here called the bucket name. Now, this should normally go into the settings, so you would really have them here. But just for the purposes of this video, to have everything in a single place to see where it's coming from, I'm going to leave it here. But really, you want to add it in settings. And that's where I'm going to give the name Nick Chapsas video, which is the name of the bucket. And that is it. Now I can go straight into implementing this method. Now, the AWS SDKs have the concept of a request and a response. So to add an item in S3, you need a put request. So we're going to have a put object request over here, which is a new put object request. And we're going to set some parameters here. The first thing we need to set is, of course, the bucket name. We need to tell this thing where to upload those bytes, that file. Then we have the key, which is effectively the full name of where this item is located in the bucket. So you can do this in many ways. You can say profile images over here, and then have, we can even separate that with an underscore, and then have the user ID over here passed with string interpolation. So we can do something like that, and then that will be the value, the key for that image, meaning that when I want to retrieve it, I'm going to use that to retrieve it back. Then we want to get the content type. I can get that from the iForm file over here. So I'm going to just send it over. And then many people make the mistake to try and use the content body parameter, but actually it's better to use a stream, so we can actually have the input stream, the stream that we're going to be pushing into S3, the stream of data effectively. To get that from the form file, all I need to say is file.openReadStream, and that is it. That will then read the stream and upload it into S3. Now, something I also like doing is uploading some metadata with that file. Metadata is just extra parameters that you control that might be useful later. So in this case, if I can grab an extension, I'm grabbing it using the path.get extension to get the extension of the uploaded file. And then the original file name as well is also stored for other purposes. Now you might say, Nick, what if the user doesn't provide an extension? Well, when someone uploads something, you can limit if they can upload a JPEG or a PNG or whatever type of image it is. So we assume that we're going to have that. And then to actually trigger the upload, all you need to say is return await s3.put object async. And then we're going to send over the request. And that is it. I'm going to turn this into an async operation, and that is it. That's how simple it is to go ahead and just upload an image in S3. Now, for all this to come together, we need a bit of wiring. So I'm going to go into the program.cs and add a few lines of code. First, I need to say builder.services.add singleton, and I need to add the Amazon S3. So Amazon S3 service, and then Amazon S3 client is registered, and then builder.services.add singleton again, and I'm going to say customer image service, and that's it. So with all the DI stuff wired up, I'm going to go back to the controller, inject that service, so private read-only customer image service, and use that. So here we go, constructor injection, grab that, and then say var response equals await customer service to upload image async, pass the ID and the file down, and then we're going to have a basic check. So if response.status code is okay, then return okay. Otherwise, we're just going to leave this as it is and say bad request. You could handle exactly what happened in the response and actually throw a friendly message, but we care about the happy path here. So I'm just going to say upload, and I'm going to go ahead and just run this API now and upload an image. So I'm going to go to Postman over here. I have this upload customer image thing, and this is using the body parameter from the form data, and I'm saying here's the data key, which is the data key we are going to accept here in the from form parameter. And then I'm going to say select a file, and I'm going to select this face.jpg over here. So I'm going to select that and upload it, and as you can see, less than half a second and the value has been uploaded. I'm going to go now to the cloud and see that uploaded image. So here we are, we have the buckets. We're going to select this, then refresh, and as you can see, we have this profile file images folder, which is not practically a folder, but it's just a grouping on the visual side of things on the cloud. So I'm going to click on that. And as you can see, we have the image. However, I can't just click on this and see it because this is not exposed publicly to everyone for everyone to see. What I would have to do for that to be allowed is to actually allow this to be viewable. This has to do with the controls of AWS. I could very easily do that if I wanted to. In fact, I can just say, for example, share with a pre-signed URL, which will allow you to get a URL that is authorized on the URL itself. So I'm going to just do that and say that this is visible for like 5 minutes, for example, generate the pre-saved URL. It is now copied. And if I go and I try to access it in the browser, I'm getting this face on the browser. So now my image is uploaded. What if I want to retrieve it? We're going to go back here and it is largely the same concept. So I'm going to do retrieval and deletion as well in the same time. So let's start with retrieval. We have the same request and response concept. So I'm going to go ahead and create my new method. I'm going to first add it into this interface. So this is going to be a get object response return value, and then the ID, the user ID or the image ID here. And then I'm also going to add delete, and it's the same delete object response. We get the ID and that's it. So I'm going to go here, implement missing members, both get and delete. And the concepts are very similar. To retrieve a file, all you need to have is the get object request parameter over here, and then simply do the same awaiting and return the value back. And I'm going to turn this into async as well. And then to delete, it's the same exact thing with the same parameters as a get, but with the delete object request, not with the get. And that's that. That's everything you need to get and delete an image in AWS. Now, on the controller side of things, we're going to have this get request over here, which is a get image request. We get the ID from the route. Again, same thing, same endpoint as well. But now we need to get that image, get the stream, and return it as something that you can visualize. So we're going to say var response equals await service and then get image based on its ID. So we have the response back. I'm going to say return file, which is coming from that controller base extension that we have. And then we're going to say response.response stream, so the stream of that object. And then because we need the content type to let the browser or whoever is consuming it know how to visualize it, we're going to say response.headers.content type. And that is it. Now, on the AWS SDK side of things, if you try to get an image that doesn't really exist, you're going to get an exception. So what we want to do here is actually wrap this into a try catch. And we want to catch this Amazon exception. We can catch it by saying catch an Amazon S3 exception where the message is the specified key does not exist. That's what AWS will throw. I'm going to just copy all that, paste it here, turn this into a nullable object now because it might exist or it might not exist, and then just return null here if it doesn't exist. And that is it. That means I have to update the interface as well over here. But once I have that, I can go back here and I can say that if response is null, then return not found, which is what you'd expect an API to return if that image is not found. Otherwise, return the file. And now, before I implement delete because I'm too excited, I'm going to go back here, run this, go to Postman and try to get the image of this user, which is me. I'm going to say send. And as you can see, wow, that's too big. It is returned. Last thing we're missing here is delete. Straightforward again, same thing as before. We're going to delete the user. If the status code is no content, then that's how we know we actually deleted the value. If the status code is not found, then that means that the value did not exist. And for anything else, we're just going to return bad request. And that is it. So we covered all the CRUD related concerns, because if you want to update something, you're just going to use the post again. If you want to retrieve something, then get. And if you want to delete something, delete. Straightforward. Now here's where it gets extremely interesting and where the power of the cloud actually comes in. S3 has this concept where when a file is added, you can trigger an event based on that file. Meaning that when someone uploads an image, which in this case is 1000 by 1000 in terms of width and height, you might not want to store that. You might only display images on a 500 by 500 limit. This means that you don't want to store long-term something that is 21 milliseconds. You also might not want to store it the way it was uploaded. You might want to have some filtering happen to reduce the size of the file itself. So maybe some lossless compression or even lossy compression, depending on what you want to do. Maybe you do what Patreon does, where before you become a Patreon, you can actually scroll a page and you can see with a blur the posts of that user. So this is, for example, my own Patreon page, and you cannot see what's happening behind the scenes. And that's good because, For example, this post over here has a discount code specific to my patrons, which is one of the benefits. So I don't want to leak that. They're going to do that on the server side and then just return the blurred version, because you don't want people to go here and say, oh, actually inspect element, find the image and try to unblur it on the client side. This does not exist. This won't happen. This is done on server side. So how can we do that? Well, we can do that by actually listening for those change events using a Lambda, an AWS Lambda, which is a small piece of code that can just listen to those events and then trigger on those events and do something about them. So we're going to see how we can do that here. Now, before we go any further, if you're following along, you're going to need at this point to have the AWS Lambda templates installed using the .NET new install command and then amazon.lambda.templates. And you also want to have the .NET global tool. So .NET tool install global amazon.lambda.tools. This will allow you to have access to the AWS related commands, which will allow you to build and push your .NET code. Now we're going to start this by creating a Lambda first. I'm going to just close everything here and I'm going to say add a new project. Assuming you installed those templates, you're going to see the AWS templates over here. So the one I want is this, the Lambda simple S3 function. So I'm going to give it a name like image optimizer over here, and that's going to have everything I need to actually build it and deploy it by default here in this configuration. So the only thing I really care about is this over here, which is the main piece of code that will do the processing. Now it comes with a bunch of things out of the box, but some of them I do not need. It adds, for example, an extra constructor to make this testable. We won't be showing testing as part of this video, so I don't need this here. I also don't need all the comments because I will be explaining things. So I can simply just do something like this over here and remove this constructor as well. And likewise, no comments here, but the rest we can actually keep. Now, just to give you an idea of what's happening here, this function handler will be what will be triggered by that action, that event of an image or a file being uploaded. So when a file is uploaded, an S3 event will come in here and will trigger this function, and we're going to get all the records in that event, which will be multiple event notifications. And then those notifications do not contain the actual bytes of the files. They contain enough metadata so you can retrieve the file. So for example, what's happening here is we get the bucket name and the key, which if you remember is the things we need to know where the file is located. And then in this example, the client is used to get the object metadata, but you can actually use the file itself to get the object. You can say get object and you can send your get request or get object request and get the file in the Lambda. So ultimately, where we're going to be adding our code is actually here in this try block. Now, just to give you an idea of how everything hangs together, I'm going to just revert the change and I'm going to just leave it as it is and deploy it as it is. So you can see that when we upload an image, we're going to get the content type of that image logged in the cloud, so we can see what we uploaded. Now, it is extremely easy to deploy this Lambda, assuming you have installed the .NET Lambda CLI tool that I showed you. So we're gonna go into the folder of that application and just say .NET Lambda deploy function, and then the build is gonna automatically happen for us. It's going to ask us to provide a name for this Lambda, so I'm just gonna say image optimizer over here. And then it's also going to ask us to create a role. I'm going to say just create a new role. What do I want to name this? Image upload video role, just for this video. And then it's going to ask me to select parameters for this role. Now, you only want to limit what this Lambda can do to the things that it should be doing. So if its purpose is to read from an S3 bucket and upload somewhere else, or just write to the S3 bucket, you want to make a role and give access only to those actions. Now, I'm making a video. I don't want to be nitpicky about the ones I use and have to go back and forth in case I choose the wrong one. But you want to be using the limited one, the right one, to only allow you to do what you should be doing in S3, which in hindsight, I think the AWS Lambda execute would actually work. And that's because it provides put and get access to S3 and access to CloudWatch logs. In any case, now this has been pushed, which means I can go back to the portal and go to Lambda over here. And then I'm going to see my Lambda function image optimizer uploaded, up and running. And what I need now is to actually add a trigger, because yes, it is there, it is out there, but it doesn't really listen to anything triggering it. So we're going to add a trigger to that Lambda. We're going to select a source. We want the source to be an S3 bucket. We're going to select our S3 bucket over here, the Nick Chapsas video. This is the bucket. And then we can choose which events we want to listen to. For example, put, post, copy. There's tons of things you can actually listen to. The ones we want here is only put actually. And then you can have a prefix on the subset of things you want to listen to. So in our case, it is profile images or profile image. I have to check that again. Let's go back to S3 to see what I named that suffix. But the suffix is sort of the bucket name you want to listen to. So you don't have to listen to everything. Yes, it is profile images, and that is it. So everything there will be listened to. And you can also have a suffix that you allow. So if you only want to listen for JPEGs, you can say .jpeg. If you only want to listen for PNGs, .png, and so on. We want all images here because they should only allow images to be uploaded. Now, a very important thing here is that you can actually have recursive invocation, meaning that if you upload an image and then you have a Lambda that takes that image event and then it does something to the image and you re-upload it to that same location, then you can have a self-triggering event where you just keep doing that forever and ever and ever. The recommendation here is that you listen to one prefix and then you upload to another prefix, or you can do something else, which I'm going to show you in this video as well. So I'm just going to say, I acknowledge that, and then I'm going to say, just add this. And now we have that trigger in place, meaning that if I just go back, run this API, and I re-upload my face, and it should have been re-uploaded now. And as you can see over here, the log entry where we log the content type, which is what we have in here, is in place. So everything is working. We can listen to those events when they happen. So now with that in place, what I want to do is go back to the function and write the code that allows me to listen to that event, get that image, resize it, and then resave it. Now I'm going to leave this response thing, this metadata thing, because I actually do want the metadata of that object. So that's a good call to have here and use. Then what I need is actually the stream of the file. To get that, what I have to say is await using var item stream equals await S3 client dot get object stream async. So we have all the metadata. So we just want the stream itself. And then we want to pass down the bucket name and the object key. And we're going to also provide an empty set of metadata, which we do not need for this request. And that will give us the item stream, the actual bytes of the file. Now, as part of this processing, I want to compress this image and make it smaller as well, resize it. And we can use the very popular image shop library for that. So I'm going to go ahead and just install it in the Lambda project itself. And then what I can say is using var outstream equals new memory stream, the stream we're going to write into, and then using var image equals await image dot async or load async, and we're going to get the item stream over here to load it. Now, once I have that, I actually want to mutate it. So the method I can use is image dot mutate, and I can say, hey, x dot resize this to 500 by 500 using this resampler approach. Now, for this image processing, I need the appropriate encoder for, let's say, JPEGs or PNGs. So what I can do is actually use the fact that I uploaded the original name as a metadata parameter here and get the original name in here. And now, since I have that, I can say await image.save async and then write that into the outstream and get an appropriate encoder. As you can see, you have many GIF, JPEG, BMP, and so on, PNG. We're going to say image.detect encoder based on that original name. And that is it. Now we have that image resized. And by the way, you can do many things here. So if you want to have the same blur effect that Patreon has, you can say a Gaussian blur or median blur or bokeh, whatever you want. The library can do tons of different mutation effects. So now that I have that resized in memory, what I want to do is the same thing as before and just use the put object method to write it. And we have the same sort of metadata parameters passed in as well. However, we are going to provide an extra metadata parameter here because we're going to be writing back to that original location. And that's just because we don't want to actually store whatever the user uploaded. We want to store just that single value, and we don't want to have a re-triggering of the Lambda. For that, all we're going to say is a new metadata parameter x amz meta resized. And that, in this case, will be true to string. And that is it. Now, for this to work, what we need to do is go all the way up here and say that, hey, if response.metadata and resize is true, then you can simply log that item with key has already been resized, continue. And that will now be ignored. It's not going to re-trigger an event ever again. It's going to come once again. We're going to check that it's already resized and then just ignore it forever. So now what I'm going to do is go back over here and just redeploy the Lambda. So I'm going to say again, image optimizer when I'm asked. It's going to detect that it's already a Lambda that exists, so I won't have to provide all the roles again. I also won't have to recreate the trigger. So with that now upload, I'm going to go back to the API, run the API, and upload the image. So I'm going to go back to the API and say, upload the same photo again. And the photo has been uploaded. However, let's go and get that image. Remember, it used to be 1000 by 1091 or 93 kilobytes. Let's see now what we have. We have a 500 by 538 kilobytes. So almost 1/3. And all that processing happened in the background using a trigger with the Lambda. We can actually go back to the logs here and see exactly what happened. So I'm going to refresh. And as you can see, that's what we have. And we can see over here that, as you hopefully can see in this log, that item with key, whatever came in to be processed. And we could actually be a bit more clear over here, and once the processing happens we can say resized image with key whatever. So let's actually quickly do that. And as a fun thing as well, why don't we also apply some Gaussian blur? Why not? Who cares? So I'm going to do the resizing first and then apply the blur. I'm going to quickly redeploy the Lambda exactly as it is, but with this log entry as well to know when something was actually resized. It's going to ask for the name, image optimizer, update the function. The function is updated. So I'm going to go back here, run the API, then go to Postman and re-upload the image. If you're very fast, because it takes some time for the Lambda to trigger, like a few seconds, then you can actually see the image before it's mutated. So I'm going to say send, go back, send quickly. And as you can see, I have the full thing. But if I do it again, as you can see, I have both the blur over here and the resizing and an even smaller amount. It's a very cool concept that you can have this asynchronous processing. And by the way, you do not have to mutate the original image. You can actually keep it as an archive type of thing. And you can just use that as the original copy to then generate as many things as you want. It might be a very small thumbnail. It might be a resized version. You might want to have a blur. What you can also do, which is very interesting, is you can actually go to S3 and enable versioning. So you can actually see all the versions of an image. So if I say enable bucket versioning over here, and then I go back, rerun this API and re-upload this image, then watch what happens. I'm going to have this image uploaded. So as you can see, it's going to be big again. And after a few seconds, the processing will happen and it's going to be small and blurred. But I can go back here, close this. I'm going to say versions, and then I can see and use all the versions since I uploaded this image. So I can actually see the original over here. I can simply say open and you can see it. It auto-generates a signed URL so I can actually display it. But I can go back and I can see the latest version, which is this small and blurred one. It's a very nice thing. And if you want to see more in detail, then check that AWS free course. We really go into detail in many of those topics. But now I want to know from you, have you seen something like this before? Have you done any sort of image processing? And what do you think about this asynchronously cloud computing? Leave a comment down below and let me know. Well, that's all I had for you for this video. Thank you very much for watching. And as always, keep coding.